Hi friends, let's discuss about a dairy farm management system through linear programming model. Just in front of you, a typical questions on dairy farm management. One side, there are two products that have been coming from the particular dairy, that is milk and cow dung. 1 unit of milk requires 2 kg of roughages and 3 kg of the concentrate. Similarly, 1 kg of cow dung requires 3 kg of roughages and 1 kg of concentrate. Every week, the particular farm has an availability of 90 kg roughages and 40 kg concentrate. 1 unit of milk yield 45 rupees price in the market, and 1 unit of cow dung has the 3 rupees as the profit in the market. The question is, how many units of each product, milk and cow dung, should be produced per week so that the farm can earn the maximum profit. It's a typical linear programming model. Why I am saying the typical one? Because there are some objective. Objective is the maximization of profit. Maximization of profit. There is some constraint here. Constraint is availability of roughage and concentrate. Knowingly I have taken roughage and concentrate because you know that almost 60 to 65% of the cost in dairy farm management system is going in the form of the feed and fodder. Then there are some assumptions. It is a linear programming model, that's why all the variables are linear in nature and no variable is -1. Non-negative conditions of variables. Okay. Then second part is that let's there are two products already highlighted, cow dung, and in the particular farm produce x kg cow dung and y kg x kg milk and y kg cow dung, and though it is the objective is profit maximization, suppose profit is z and that should be maximized because you know that 1 unit of cow milk produce gives 45 rupees in the market. That's why 45x plus 3y, that should be 3y should be your overall profit. Just I take it bit right side and I put here that it is the dairy farm and the objective is the maximization of the profit, and that maximization should be z equal to greater than or equal to 45x plus 3y. It's very simple. Then in the same manner, what should be the constraint? The constraint is one of the constraint is roughage, already highlighted in the website. And what should be the roughage constraint? That one milk requires or 1 kg of the milk requires 2 kg of the roughages. X kg of the milk requires 2x kg of the roughages. Similarly, 1 kg of cow dung require 3 kg of the roughages. Y kg of the cow dung requires 2x plus 3y kg of the roughages. Similarly, regarding concentrate, the similar pattern of the equations you can write that is 3x plus y, but limitation is that the availability of the roughages and concentrate has some limitations, and that limitation is 2x plus 3y. 2x plus 3y equal to less than equal to 2x plus 3y should be less than equal to already highlighted 90 kg, and 3x plus y should be less than or equal to 40. It is a typical way of representing data from the equations just in front of you. But during the solving of the particular questions, I just make the informations bit little bit change. I have to do that. You just mark that what I am changing in the particular questions. The variables that okay. The variables uh, you have to find out that how many kg of milk you have to produce in a particular week and how many kg of cow dung you have to produce in a particular week, by which your profit from the dairy farm should be the maximum one. This should be variables one. You don't know about what is x and what is y. Similarly, objective, here I am writing that 45x plus 3y. Can I write that z equal to 45 and 3, 45 and 3, and it should be greater than or equal to sum product of sum product of 45 and 3 comma whatever the variables will come forward. I can write that in this way. Just imagine in the typical school days exam, 1 kg milk produce gives 45 rupees. Suppose x kg milk, then 45 into x plus 3 into y. That's why I written here that is the sum of the product. Okay. Similarly, in the constant part also, I just write 2 and 3. Okay. And similarly, concentrate, I can write 3 and y, and whatever the variables will come, that should be sum product of 2 into 3 to the value 2 into 2 and 3, the particular cell, and whatever the value will come here in the form of milk and cow dung. Similarly, in the concentrate part also, that is also the sum product of the particular array into the particular variables come in the form of the milk and cow dung. I just make it cell. Okay. Let's go to the solve the particular questions. I just make it in bracket. That's it easier for you to understand the things. Okay. In the data, you know that there is a solver. I just reset all. I reset all because previously I done that. What should be your objective? Your objective cell should come, that is Z. That is your objective cell. That should be objective is the maximization of the profit. That should be the maximizations. Which variables you need to change? That is my variables, how many kg of milk and how many kg of cow dung a farm need to produce. And what should be your constraint? Your one first constraint is that 2x plus 3y should be less than or equal to 90. And second constant is 3x plus y should be less than or equal to 40. Okay. Then check all the things whether it is the right way or not. It's the maximization form. Profit should be maximized. Variables I have highlighted. Constant I have highlighted. Non-negative conditions I have checked. Simplex methods. And I just solve it. Once I solve it, I found that the particular dairy farm, by managing its roughages and concentrate, the particular dairy farm can survive by producing only 13 liters of milk per week, by which its profit can go up to 600 rupees. Or you can say that by getting maximization profit of 600 rupees, the particular dairy farm can only deal with 13 liters of the milk. If it is less than that, then the things will be again relook. But whatever, by giving 26, I just make it full because it is easier for to understand. A particular dairy farm should produce give 27 kg of roughages and 40 kg of concentrate to its dairy, by which the particular dairy can produce 13 liters of the milk. Accordingly, the dairy will generate 600 rupees as the profit by managing the roughage and concentrate. But in real life situation, in the dairy farm, you know that numbers of variables are there or inputs are there, labor is there, insurance are there, medicines are there, pattern of managements also be there. So numbers of things can be changed. Here I have taken roughage and concentrate in the form of the quantity. I have not taken the price here. If quantity will come, price will come, then your constraint to deal the things will also be changed. I will bring the typical of complex managing the dairy farm in my future video. But in the real life situations, handling the roughage and concentrate, whatever your constraint of availability of the resources in the particular dairy farm management, you can generate 600 rupees by producing 13 kg of the milk only by giving 27 kg of roughages and 40 kg of the concentrates to the respective dairy. Hopefully, today's lecture is useful for all of you. Be connected. I will bring more videos in subsequent lecture series. Thank you.